Hi friends, today I will go through some Snowflake scenario based interview questions those were asked in interviews. So the first question is how to give sequence number to newly added column in a table in Snowflake. Suppose there is a table with some number of columns and I want to add one more column to the table and I want to assign some sequence number to that column. So is it possible in Snowflake? If yes, how? Okay. So suppose take this example. So where I am creating a table ABC with only one column and I am inserting some values into this table. Otherwise, let me explain through Snowflake editor. Okay, so suppose I am creating a table, create table ABC with only one column. Okay, so table has been created. I am inserting values into this table, some values. Okay, so 8 rows inserted with one column, and now I am altering this table. Okay, so I want to add a column and I want to assign sequence number to that, right? So I am inserting one more column with the name column 2 of data type number. Okay, now, how to assign the sequence number? This is important. So we have a concept called sequences in Snowflake. That means we can generate a sequence of numbers. Suppose uh, the syntax for that is create sequence sequence 1. So we have to give some name for that sequence we are generating. So I am generating a sequence here. And how to assign that sequence to the existing table? So we have created one table and added a new column of type number, right? The column name is column 2. So now I am updating the table. Update the table ABC, set column 2 equals to, we just have to put like this, sequence 1 dot next value. That means it will increment the sequence value to next number and it will assign to all the rows present in this in the table. Okay, so let's execute that. Okay, now see the data. Okay, 8 rows got updated. So let's see the data now. So if you see here, earlier there was only one column with A, B, C, D, E, F. Now if you see, we have generated one more column and assigned the sequence number like this: 1, 2, 3, 4, 5, 6, 7, 8. So by using the concept of this sequence, we can assign a sequence number to the newly added column in the Snowflake tables. Okay, just remember the syntax is create sequence, some name to that sequence, and how to assign. Not only while updating, while inserting also you can use this sequence number. Simply you have to put sequence name dot the dot next value. That's it. Okay, so the next question is, while apply masking to a date field, can I show only year and rest of the date can be masked? If yes, how we can achieve that in Snowflake? Suppose I have explained about data masking in my videos where I explained about how to mask the numeric types and varchar or string types. But I have a question. Okay, so can I apply the same on the date fields? If yes, how? Okay, so we have that feature in Snowflake. Yes, we can do. We can apply masking on the date fields. Suppose if the column is date, then we need to return a valid date. So whenever we are applying masking on date field, so the return type also should be date. It should return some date. Okay, so maybe you can truncate the dates up to the years. Suppose I have a proper date with year, month, and number. If I want to truncate up to year, okay, I can do that. So how we can do? This is the syntax for that. Create or replace masking policy, some masking policy name, and masking policy as okay. So I am giving this value of date type, and I am returning date, returns date, and so what is the code here? So case when current role in admin, so only admins, okay, or whatever the role we set, they can see the actual value, actual date. For all others, just date. I am applying one function in the Snowflake date trunk of year comma value, year comma value. This is my code. Case when current role is in admin, only admin can see the actual date value, and for all others, you truncate this value up to year. Show only year and don't show the date part and month part. Okay, so this is the code. So suppose for example, so if the date is 2022 11:30, and if we apply this code on this date field, it will show like 2022 0101. So we cannot apply like some asterisks or into symbols or star symbols like that here, because as this column is a date value, date type, we should return some date type only. So you cannot put characters. Okay, that's why. So here I am truncating up to year only. Okay, so the month and date part is showing as some default to 1 1. Like that it will work. So if you need some information on date trunk, so you can run these examples. Select date trunk of year comma current date. Okay, if you want I can show you this as well. One second. So let me take this. Okay. So suppose if you want to know more information about date rank, so what it will do, okay, when I do like the date rank of year comma current date. So current date is uh, this one, right? 2023 213 Feb 13. So if you see here, it is showing only 2023 0101 because I am truncating up to year. Uh, Except year, everything will be truncated. Okay, suppose if you want to do the same, if I want to truncate the timestamp also I can do. Suppose from the current timestamp I want to select only year and rest everything should be some default. Okay, so like this you can do. Suppose if I want to truncate up to month from the current timestamp, so you can do this. Okay, so if you see here, the month is 2 and rest of the thing everything is 000. If you want to see till day, okay, I want to see only the date part, but I don't want to see the timestamp part. So in that case, you can do like this. Okay, so today's date is this one, but time it is not showing because we are truncating the remaining part. Okay, like this you can use this date trunc function in Snowflake. Okay, so I hope you understood how to mask a date field in Snowflake. Okay, so the next thing is next question is one of your query is taking long time to run. So how can you handle in that situation? Okay, so there can be lot of reasons why a query is taking long time to run. So we can resolve. So by simply looking at that query, you cannot say anything. So we have to go through some steps. Okay, so we can resolve this issue with the below steps. First, we have to check that query is in running state or is in waiting state. Okay, if it is in waiting state, we have to check how many clusters of virtual warehouses we are using and how many concurrent queries are running. Okay, so if it is happening every day, then definitely we have to scale out. That means we have to increase the number of clusters so that we can avoid queries going into waiting queue. So you may be thinking like that the query is still running 1 hour, half an hour it is still running, but in the background if you check, maybe it was not running. It was in waiting state because of there are no resources available to run. So in that case, if that case is daily happening and you are running on a single cluster, then you have to increase your number of clusters so that you can avoid the queries going into queues. Okay, so this is the first thing we have to do. Then second thing is, if query is running, suppose a query is not waiting, okay, query is in running state, then check how much data we are handling and your virtual warehouse size. Okay, so we have to check that. Suppose if we are dealing with the millions and billions of data, and if we are using a extra small warehouse, definitely there can be a performance issue. In that case, what we have to do, so if we are daily dealing with the millions of data and we are working with extra small virtual warehouse, then definitely we have to scale up our virtual warehouse to next available size or the size whatever it is required, like small, medium, or large. Okay, So this is the second step. So the third step, still suppose I'm using my query is not in waiting state and I'm using good size of virtual warehouse. Still the query is taking time to long time to run. So in that situation, how we can deal? Okay, so what we have to do, go to the query profile. So we have a query profile thing available in Snowflake. Whenever you click on that query ID or go to query history, so you can see that query profile of any query we ran previously. Okay, and if we go to that query profile, it will show the flow diagram of steps, and it will show all the diagrams. Suppose if we are running 10 lines of query and we are using so many functions, joins, everything, so it will show all the steps, so where it is joining, where it is filtering, where it is grouping, everything, and it will show which step is taking long time to run. Okay, based on that step we have to take some action. So we have some performance tuning techniques, right? So I have discussed almost 10 performance tuning techniques in my previous videos. So if this is the case, we have to look into which step is taking more time and how I can tune that query in that step exactly. Okay, so if we running same queries again and again, enable cache, it will improve the performance a lot. This is one of the idea how we can um, increase the performance of our queries. Suppose if there are a lot of users, they are running same queries every day, or only one user running the same query multiple times a day. So in that case, what we can do? So we have to always enable the cache. So there are two types of caches I have discussed already, right? So we can enable that cache and it will improve the performance a lot. Okay. Okay. So next question is how pivot works in Snowflake. So this is very important. In traditional databases or on-premise databases, we did not have the exact direct way of pivoting or unpivoting, but in Snowflake, it's very easy to pivot or unpivot data. And even in the interviews, you may be asked so many times, like I have some input data like this, and I want to see the output like this. Suppose first, let's see what is pivot. Okay, pivot operator converts the rows of data, rows rows data of the table into column data. So pivot is a operator. It will convert the rows data into columns data. So this operator support built-in aggregate functions. Okay, so after aggregating the row, it will convert the rows into columns. So what are the aggregations supported by this pivot? So like average, minimum, maximum, count, and sum. So all these functions are supported by this pivot operator. Suppose let's see with one example. I have a data like this. Okay, employee ID, amount, month, and I have different rows like this. For example, for employee 1, so this is the amount and this is the month, January. Okay, for same employee, so this is 400 in January. Okay, for employee 2, so I have different rows like this. Okay, so in that case, so for example, if you see for employee 1, the data is there for January, February, and March. Even for employee 2, the data is there for January, February, and March. So I want to see like this employee ID, January amount, February amount, March amount in different columns, and I want to see the values like this. For employee ID 1, what is the January amount? For employee ID 2, what is the January, February, March amount like this? So this is my input, and I want output like this. So we can uh, easily do this in Snowflake by using this pivot operator. So what we have to do? Simply select star from monthly table, monthly sales table. Select star from suppose this is a monthly sales table. Okay, select star from this table. So we have to apply pivot on sum of amount. So I want to see aggregate this sum into columns, right? So what I can do, sum of amount. Okay, so for January, there are multiple rows. Suppose if you see here, 10,000 and 400. So if you sum up this, what it will become? 10,400. So sum of amount for month in January, February, March. So if I have so many months of data, if I want to see only January, February, March, so I can mention like for whatever the months I want to aggregate and see. Okay, pivot of sum of amount. So whatever the column we want to see the we want to calculate the aggregate functions, and for month in whatever the months I want to see that aggregated amount as P. Okay, so I am putting one alias name as P, order by employee ID. Okay, so this is very simple. So we have to apply pivot on sum of the amount, so the aggregate amount, and so what are all the months I want to see this data. Okay, like this we can apply the pivot, and if you run this query, the output will come like this. Okay, so this is pivot in Snowflake. Okay, so we have unpivot as well. So unpivot operator, what it will do, it is simply opposite to the pivot. It will uh, deaggregate the data. That means it will convert the column based data into rows. Okay, so this is exactly opposite to pivot. Suppose let's see with one example. I have input like this: employee ID, department, January, February, March. Okay, so I have data like this one. Department is electronics. For January amount is this one, February this one, March this one. Now I want to see output like this. For employee ID one. So what is the for department electronics? Okay. So for month what is the amount? For the January month what is the amount? For February what is the amount? For March what is the amount? I want to see in different rows, not in all in same row. I want to see in different rows with these columns, month and sales. So in this case, we can unpivot this. So we have this columns. We have the data in columns, different columns. So 1 month data, January data in one column, February month data in one column, March data in one column. But I want to unpivot that to rows. Okay, January data in one row, February data in one row, March data in another row, like this, columns to rows. So this is also very simple. Select star from monthly sales table, unpivot. Okay, sales. Okay, so this is the name I want to give. Okay, so unpivot sales. So if you see here, we don't have sales column. So whatever we are giving here, this will come in the output. Okay, for month in, this column is also not present here. I want to see here. Okay, in the output for unpivot sales for month in. So we have to put for whatever the months we want to generate new rows. Okay, so if I have some 4 or 5 months like this, if I want to see only for months Jan, Feb and March, I can simply apply on this. Okay, like this sales for month in, simply opposite to this one. There we use pivot and do aggregate. Here we unpivot and we see the data in different rows. Okay, so like this you can apply unpivot. Okay, so if you want to practice this pivot and unpivot queries, so in the Snowflake documentation they have given these examples very clearly. So from these links you can get so the pivot and unpivot, or you can go to Google and you can type like pivot in Snowflake. So that will take to you this page. Here there are examples, and it was clearly explained here how pivot happens, how unpivot happens with some examples. You can go there and you can practice. So the next question is, so how to get dropped table data if we recreate a table with same name as drop table. Suppose let's see with this scenario. So there is a table with the name employee with some 1000 records. Okay, so on day one I have dropped this employee table. Okay, so the employee table with 1000 records I have dropped. On day two, what I did, I have created a table with the same name EMP, and I have inserted 5000 records into the table. Okay, so on day two I have created a table with same name. Okay, and inserted 5000 records. On day three, so I need the data from employee table that I had dropped on day one. Okay, now on day three I have realized I need the data which was dropped on day one. So how can you get the data? Okay, so how can you get the data from day one? Now I want both data. So whatever I dropped on employee table on day one, I want this data as well, this 1000 records, and I want these 5000 records as well. So how can you get that? Okay, so these are the things we have to do. Okay, I will explain this with some example. Okay, suppose first what we have to do, we have to rename the employee table on day two. Whatever we have, this table is there right currently, so we have to rename the table into some other Okay, let me show with example, otherwise you will easily understand. Suppose on day one, so I have created a table like this. Okay, so create table ABCD with the two columns, column 1 as integer, column 2 as varchar, and I'm inserting two records like this, 1 ABC, 2 XYZ. Okay, so if you see the data from this table, it will be like this. Okay, two rows inserted, and if you see the data, it will be like this, 1 ABC, 2 XYZ. Okay, so I felt like this table is not required. Okay, I am dropping this table. Okay, now the next day I have created a table with the same name. If you see ABCD with the same name but a different structure. See, I'm here I'm putting three columns in this table, column 1 integer, column 2 varchar, column 3 of date. Okay, I have created, I am creating another table on the next day. Okay, and I am inserting just one row, values of 101 A B C D E, and in the date I am inserting current date value. Okay, okay, so if you see the data, it is like that. Now, so if you have some idea on time travel, you can watch a time travel video from my channel. Okay, so if we have time travel enabled on this table or schema or database, so we can get this table back by using unwrap table. Okay, so so I have given queries in this presentation so that you can practice. Okay, so whenever we unwrap the table, we can bring back the table. So let's apply unwrap. Okay, but it is saying so you are trying to unwrap the table, but with the same name already one table exists, so I cannot unwrap. So in this situation, how we can handle? Okay, so what we can do, so first of all, this ABCD table is the day 2 table, right? So I am altering the table and renaming it to ABCD underscore day 2. Okay, okay, so now I have backup of this table, the current table. Now what I am doing, I am doing unwrap table ABCD. Okay, so so whenever I unwrap ABCD, so whatever we dropped here on the previous day, okay, so it will come and it will be there in the ABCD. Now I am, what I am doing, I am renaming this table like alter table ABCD, rename it to day 1. Okay, because this is holding day 1 data, right? Okay, and we have day 2 data backup in the ABCD day 2. So what I am doing, alter table ABCD day 2 back to ABCD. Okay, now so this ABCD table is holding the current day's data, so we are not disturbing that, and we got the data which we have dropped on day 1 into this table ABCD day 1. Now I have both data, so if you want to check, let's see, on the day 1 data there should be two records, right? So you can see one ABC, two XYZ. On day 2, this table I should have one record with three columns. See here, 101 ABCDE and some date column. So now we have both the data sets. So this is how we can handle whenever we create a drop table with the same name. Okay, I hope you understood. If not, try to listen whatever I explained one more time. Okay, so I have given the queries for practice. And next question is, it's a question on the clone table. Okay, so let A is the original table and B is the clone table. So if we insert a data into table B, will it reflect to table A, and what happens to the storage? Okay, so the answer is After cloning, there will be no impact of rows insertion or deletion on either of the tables. That means if you insert or delete records in table A, it will not be reflected in table B. At the same time, if you insert or delete some record from table B, it will not reflect on table A. But when it comes to the storage, definitely there will be some impact. Okay, how? Let's see. Suppose original table A contains 1 million records. Okay, and I have cloned it, cloned the table A to table B. So after that, I have inserted. So after cloning, even table B will contain 1 million records. Okay, and whenever we clone, so it will not take separate storage. That is the concept of zero copy cloning, right? With a zero additional cost, it will maintain a copy of data. So now table A and table B both are having 1 million records of, but table A only contains the storage. Table B is just a clone of table A. Okay, now what I am doing, I have inserted 1000 rows in table B. Okay, so 1 million plus 1000 rows, then there will be storage cost. There will be storage cost will be only for those 1000 records which are not available in the original table. So now whatever the 1000 records we have inserted, there will be a storage cost for only those 1000 rows from the table B. For the rest 1 million records, there will be no storage cost. Okay, so now I hope this is clear. Okay, after cloning, there will be no impact of rows insertion or deletion on either of the tables, but there will be some impact in the at the storage level. Okay, so next question is on tasks. Okay, so question 8 is on tasks. When we can schedule queries by using tasks in Snowflake, why we go for third-party scheduling tools? So this is obviously everyone will get this question. So we have a very good concept called task in Snowflake. Still, why organizations are going for scheduling tools, third-party scheduling tools? Okay, so because by using tasks, we can schedule the tasks, we can schedule the queries or whatever the task and monitor them from the task history table, which is difficult. So whenever you create some task to schedule your queries or procedures, how you can monitor them? Suppose a task is failing, so how can you monitor that? So the only way is we can monitor the task from the task history table. But it is somewhat difficult, right? Because there are so many third party scheduling tools where you can monitor by using the very good user interface UI. Okay, so that's why we go for scheduling tools. Not only the monitoring, but we can but the third party scheduling tools offer UI based monitoring, and it is very easy to control the job flow. Okay, like if I want to hold some of the jobs, uh, or if I want to release some dependencies from one job to another, or if I want to cancel one of the job, or if I want to kill one of the job. So this all thing it's very difficult to do in Snowflake tasks. But if we are using some third party scheduling tools, we can do all these things, which is very important. Okay, so if you are working in a support project or in monitoring project, you should be aware of all these things, right? So based on the requirements, sometimes we need to hold some of the jobs, we need to release some dependencies, we need to cancel or kill the jobs. So these all things we cannot do by using tasks. That's why we go for um, third party scheduling tools for better monitoring and for controlling the job flow very easily. And these are some famous scheduling tools used in the market like Control M, Airflow, Ansible, TWS, ActiveBatch, Jam Scheduler. Okay, so the next question, question number 9, how can I convert my Teradata DDL to Snowflake DDL? Or how can I convert my SQL Server DDL to Snowflake DDL? Or how can I convert my Oracle DDL to Snowflake DDL? Okay, so it is very important. So whenever we are migrating from on-premise database to a cloud database like Snowflake, it's very important. First of all, we have to migrate the DDL because the existing DDL may not run as it is in Snowflake. So in that case, we need to convert. If there are one or two tables, we can easily convert manually. But if there are hundreds or thousands of table, is it possible to convert each and every table manually? Definitely no. So in that case, what is the solution? Okay, so we can use there is a tool called RoboQuery, so you can get it from Google, RoboQuery, or from this by using this URL you can get it. Use this tool to convert the DDL from any database to any other database. So this is very easy tool. Okay, so let me show you otherwise. Okay, so this is the robo query. If I want to convert the DDL from any database to any database, okay, so suppose if I want to convert my DDL from Oracle to Snowflake, so simply I have to put the DDL, okay, here, and just you have to click on convert. Like the same way, not only the DDL, you can convert the uh, table DDL, view DDL, and some SQL queries also you can convert. So this is one way by using the robo query tool. Okay, but here the limitation is per day you can convert only 5 queries or 5 DDLs. Okay, so if you want to convert more, then you have to subscribe for this robo query. You have to purchase the license for this. Okay, so this is one way. Otherwise, if you don't want to purchase the license, still if you want to convert DDL to Snowflake, so you can develop a Python script to convert all the DDL at a time. So if you have some knowledge on how the Snowflake DDL should be, and if you have some basic Python knowledge like how to do find and replace, okay, like that, if you have that skill, you can easily convert all the DDL at a time by using this Python script. Or the third option is we can write a stored procedure in Snowflake itself, which can convert the DDLs to Snowflake. Okay, so this is also one option. So we have to write a procedure that will take your Oracle or Teradata DTL as the input, and it will convert the DDLs to Snowflake. Okay, so these are the some of the ways. So question number 10. Okay, so what is the difference between full load and incremental delta load, and how we can choose, how to choose, which one we have to choose? Okay, so this is the question, and the answer is if in full load, the complete data set will be loaded every time where we delete or truncate the target table data and load the new data set. So in full load, so we can fetch the complete data set, and we can um, insert the same into the target table after deleting the complete data or truncating the table. That is called full load. Okay, in incremental loads, we will fetch only the data set that was inserted, or the we will fetch only the data that was inserted or updated after the previous load. Suppose I have a daily load. Okay, in incremental, what will happen? So whatever the data, and I have a daily load which runs at 8 a.m. in the morning. So I have loaded yesterday's data yesterday. Okay, at 8 a.m. my job ran and the data was loaded. So after 8 a.m. yesterday, so what are the newly inserted records and what was the updated records? We have to fetch only those records, and we have to do the same update or insert in the target table. We call that as incremental load. Okay, and load that to the target table by using upsert or insert operations. So upsert means updating the existing record and inserting the new records. We can pull incremental data from source with the help of some last update timestamp. So how can you identify which data to pull? So last 24 hours data only we have to pull. So we can maintain some columns like last update timestamp in the column. So whenever that last update timestamp is greater than yesterday's load time, so we can fetch only those records from the source, and by using upsert operation we can say do the updates and inserts at the target level. So now, so we know what is full load and incremental delta load. Now how we can choose, uh, l- uh, we have to go with full load or incremental load. Okay, so there are some steps. Okay, based on the data volume and load frequency. Okay, so we can decide. Suppose we cannot perform full loads if we are dealing with large data sets and we have to load every hour or every day. Suppose my I have source data in millions. Okay, and I want to do that load every hour or every day. So is it possible, or is it feasible to load mm, that complete data set every day or every hour? Okay, it's not possible, right? It will take a lot of time. So in that case, what we can do, we can go for incremental load, fetch only incremental data, and insert or update the incremental data at the target tables. Okay. So suppose if there are no keys to identify incremental data from the source, suppose I don't have a timestamp, last update timestamp my source table, then how can I identify my updated data, right? So in that case, what we have to do, definitely we don't have other choice. We have to do a full load. We have to fetch all the data from source, and we have to do a full load into the target table. Or if there are no giant keys to perform upset, suppose something I have last update timestamp at the source level, I can bring that um, data, last update data from the source table, but I need to join the table, right? I don't have any primary key defined on the target table. So how can I join this source data with the target data? So if there are no join keys, if we are not able to identify any join keys to perform this insert update operations, then we cannot go for incremental load, and we should go for full load. Okay. So question number 11. My Snowflake account was hosted on Azure. Can I load the data that is present in AWS S3 bucket or Google Cloud Storage? Okay, so this basic doubt everyone is getting, and they are getting confused in interviews. Okay, so yes, we can read the data from any of the three cloud storage providers: Google, Azure, AWS. Okay, uh, even though you host your account any of these cloud providers, still you can read the data from other cloud providers. Okay, but it is limited to only these three clouds as of now: Google, Azure, and AWS. As Snowflake does not have their own cloud, they are dependent, that means they are hosting the Snowflake account on other cloud storage providers. Okay, Snowflake doesn't have their own cloud, that's why they are just dependent on these three clouds. Otherwise there is no dependency. Like if I host my Snowflake account on Azure, then I can read only data from Azure. It's false. So even though your account was hosted on Azure, you can still bring the data from any of the three clouds. Okay, by creating the external stages. So how to integrate your Snowflake account with AWS or Azure, I have explained in my YouTube channel videos. Uh, you can get help from there if you want to integrate your Snowflake account with the clouds. Okay. So the question number 12. So write a query to get below output from the given input. Okay. So I have a table like this. Okay. So employee ID, full name, and language. This is the language details, languages details of employees. So that means the employees, they can speak what are the languages. Suppose I have data like this. Okay, employee ID, full name, and language. Okay, suppose Virat Kohli with employee ID 101 can speak English and Hindi and Marathi. Okay, with employee ID 2100, Mahesh Babu can speak English, Telugu, Tamil, and Hindi. But I want my output like this. Okay, so I don't want to see multiple rows for this. Okay, I want to see like this. Just name of the employee and what are the languages he can speak. Suppose Virat Kohli can speak all these languages. I want to separate all these values by using commas. So how to do this? Okay, so we have a function called list ag list aggregator. This will aggregate the data, and it will separate whatever the delimiter we apply here. Okay, suppose my query like this, I can write a query like this: select full name, list tag of languages. So what are the things I want to aggregate and I want to list? So the language field I want to aggregate, and I want to separate by comma. So I am applying list tag of language, and you just put whatever the delimiter here, and I'm giving a alias name for this as languages speak from employee language. So suppose this table is employee lang. Okay, so and we have to, whenever you are doing some aggregation, definitely you have to mention the group by column. So I want to apply group by on either employee ID or employee name. Okay, and I'm applying this list tag on the language field. So whenever you run this query, output will come like this. Okay, So if you want to see, I can show you. Okay, so the same data, I'm creating a table employee language. Okay, and I'm inserting whatever the data I have shown in the table of three employees. Okay, so suppose 101 Virat Kohli English, 101 Virat Kohli Hindi. Okay, like this, for three employees I'm inserting data here, and if you see the data, it will be like this. Okay, so you can see in multiple rows. Now whenever I run this query, okay, so it will come like this. What I am simply doing here, I am just group by and full name and applying this list tag function on the language field, and I can mention anything here. Suppose if I want to apply delimiter a pipe symbol, so here earlier it was comma, right? Now I want to apply this pipe symbol. So you can see it was separated by pipes. Okay. So the same example in interviews, they will ask you simply like this. Okay. So there is a table. Okay. So let me show here first. Then. So the next question is also similar to that. Question number 13, write a query to get below output from the given input. I have data like this, 1A, 1B, 1C, 2X, 2Y, 3A, 3B like this. But I want to see the output like this. Okay, 1 ABC, 2 XYZ, 3 AB separated by these delimiters. The same query, so whatever we discussed earlier. So okay, I have created this table and I'm inserting this values 1a 1b 1c 2x 2y 3a 3b. Okay, and if you see the data, it's like this. But whenever I apply this list tag function, by using this pipe delimiter, it will come like this: 1 abc 2 xy 3 ab, like this. Okay, this list tag function is very useful. If you want more details on this, you can just go to Google and you can write like list tag in Snowflake. You will get not only this, there are many advantages of list tag function. Just read from Snowflake documentation. Okay, so that is question number 13. And if you want to practice these two examples, whatever I shown here, you can get the queries from here and you can practice. So the question number 14, what are slowly changing dimensions and how do you implement them in Snowflake? Okay, so first of all, if you have some idea on slowly changing dimensions, it's good. Otherwise, first learn what are the slowly changing dimensions and what are the types of that. Okay, so slowly changing dimensions are the dimensions that change slowly over the time. So there are many types of SCDs. From I'm not going deep into this SCD types. Okay, this is just a small introduction about SCDs. So these are the dimensions that change slowly over the time, and there are many types of SCDs from type 1 to type 6. But majorly we use only three types of SCDs. Okay, SCD type 1, type 2, and type 3. In SCD type 1, it contains only current data. That means it will not contain any history data. It will contain only current data. So what it will do, whenever whenever you try to load some data, if it is a new record, it will insert. If there is a update record, it will directly update the existing record with the new record. Okay, so in SCD type 2, what will happen, it contains sorry, not only, this is a wrong word, contains current plus history data. Okay, SCD type 2 contains current plus history data. So whenever a new record is coming, it will insert that new record. And if there is any update record coming, it will not update directly on the target table. So first of all, the existing record is there, right? It will logically expire that existing record by updating some version or expiry date, like that. Some with some timestamp, it will expire that existing record, and it will load the new version of record. Okay, so the load newer version of the existing record. Okay, that means for one row there will be two rows. That means it is containing the history data as well, current data plus history of that record. So if there are if that data changed on 10 days, that record was particular record was updated on 10 days, it will contain all 10 records. Okay, so SCD type 2 contains complete current and history data. Okay, it will not delete any data, but it will just logically expire that record. And SCD type 2, it will contain only current and recent history data or limited history data. That means it will just maintain current and previous version of the records available. Suppose a record is there on day 1. Okay, so on day 2 a update came. Okay, so what it will maintain, both it will maintain day 1 and day 2. Now on day 3 another update came for the same record. Now it will maintain only current and previous. Current is day 3, previous is day 2. So it will delete the um, third day, the record that was of 3 days, that means day 1 record. So here it will maintain, SCD type 3 maintain only current and the previous version of the records. Okay, so we can easily implement this SCDs in Snowflake by using streams and tasks. Okay, I have already explained about the streams and tasks with examples in my channel. Okay, so first you have to get some idea on what is mean by task, stream, everything. Then by using these streams and tasks you can easily implement this SCDs in Snowflake. So I am giving two links where they have explained this SCD type 1 and type 2, how you can build a SCD type 1 and type 2 in Snowflake by using streams. Okay, in these links they have clearly explained with proper examples. Okay, so you can get those examples and practice so that you will understand it better. Okay. So the question number 15, in which scenarios you have written stored procedures and UDFs? So you may get a question like this, right, in interviews. So in which scenario or where you have used stored procedures, where you have used UDFs, user defined functions. Okay. So we can write stored procedures when there is a need to execute multiple SQL statements in some order. Okay, in Snowflake we can write queries, but if I want to if I want to execute multiple SQL statements in some order, or if I want to do some looping or conditional checks, if I want to execute some queries after checking condition, or if I want to execute the queries in multiple times by using the loops, for loop or while loop, in that case, we cannot directly write the queries by using loops and conditional statements, and I cannot execute multiple statements, multiple queries at a time, right? In that case, okay, if I want to execute multiple SQL statements in some order after applying conditional or looping statements, in that situation I can go to stored procedures. When there is a need to apply same logic multiple times or at multiple places with the different parameters. Okay, so this is we do in real time actually. So I want to do some processing. Okay, at multiple times I want to do the process, or multiple places I want to apply the same process. In that case, what we can do, we can simply create only one procedure, and we can call that procedure with multiple with a different set of parameters. So the logic is same, but the values are different. Okay, suppose if you want to build the same in SQL, you have to write multiple statements, right? So every time you have to write the SQL. So what it will do, the complexity will be more and the number of lines of code will be more. Uh, Otherwise, if you can just create a procedure and you call the same procedure with a different set of parameters, it will save the time, cost, everything, right? So in that scenario also we can go to the stored procedures and to automate certain things. So whatever I explained in the previous step, okay, not only with multiple times or multiple places, if I want to do some process automatically, so I can create a procedure and I can create a task over that procedure. I can call that procedure from a task, so it will run every day. Okay, so in these scenarios I will go for stored procedures. And when we have to choose UDFs, okay, or at in which situation we have to write UDFs. Okay, so what is UDF, user defined functions? First of all, what is a user defined function? So when certain functionality is not available through built-in or system defined functions. So in any database we have so many built-in functions or system defined functions, right? So we can use them in our SQL queries. Suppose if any functionality is missing in my company, okay, or in my requirement is like I want to build a separate functionality where I'll be using that code again and again, or where I'll be applying that part of a function at many places for many records. In that case, what we can do, we can create our own functions. We call them as user defined functions. Okay, so in which situation we go for UDFs? When certain functionality is not available through the built-in or system defined functions, we can create UDFs, and we can apply those user defined functions multiple times or at multiple places. Suppose, for example, I want to calculate a tax amount or sales amount of some employee or sales from sales table. So in that case, I don't want to mention that a tax amount calculation for every record or for every SQL query. What I can do, I can simply create a tax amount function, and I can call that function in my code. Okay, so like that, in that scenarios we go for UDFs. Okay, so in Snowflake we have flexibility, like we can write procedures and UDFs in multiple languages like SQL, JavaScript, Python, Java, Scala. If you see the on-premise databases, okay, so where you can write procedures only by using PLSQL, but here we have a flexibility. If you know Python or JavaScript or Scala or Java, still you can write functions in these languages. Even you can write procedures in these languages. Okay, so these are some of the scenario based interview questions asked in Snowflake interviews. Okay, thank you. And if you want all these videos, PPTs, queries, files, okay, you can get from my Udemy course for very less price. Okay, I'll be updating this Udemy content, and I'll be uploading all the new videos in my Udemy course. So this is the link to my course. Okay, and I'll paste the same link in the description of this video. So if not yet subscribed, please subscribe to my channel. And if you want everything, okay, you can purchase from my Udemy course at very less cost. Thank you. Bye.